Here I'm going to write a computer program that is going to perform a task again and again. So for Fortran 70 standard, I start program from the 7th column. So program name repeat, right? And for every program that has a beginning, there must be an end. So I write end program repeat. Okay. So here I'm going to write a statement print hello world. And then I write here go to 10. So it's a label. And I write here from columns 2 to 5, I can write the label 10. Right. So this is fine. It will work for it. There is no need if the lines are written, if the program lines are written after the 7th column with Fortran 77, it is all perfect. And in other versions of Fortran, that is also perfect. So we have to save this file with a name, with the Fortran readable extension, and it should be in the bin directory. Okay, so in E, yes, so we have been working in this directory. So normal text file, it should not be normal text file. I'm looking for a Fortran file, Fortran form source file, so that it should be identified. Its syntax is identified by the Notepad++. So here I again write repeat.for. So this has been identified as a Fortran file. So very simple program. Now to run this program, I have to access the same program from the command window or terminal. So cmd, yes, it is here. And I have to get to E directory. E directory is visible, and I have to get to G77, then again G77, then bin directory. And the contents of directory are now visible with the dir directory. So I have my file repeat.for here. And here is the compiler G77. Right. So now we have to write a compilation command that is going to call G77 to read the file and generate a binary file. So to make it visible, I clear the screen and I write G77 file name repeat.for -o, and then I write repeat.exe. That's the convention I use. You may choose other names of your choice. So this is the dangerous moment. Compilation is going on. Oh, nothing strange has been returned by the compiler. It means there are no syntax errors. But when we call the program with the executable file, it may show up with the numerical errors. So repeat. So hello world several times. It is not going to stop, right? It means it has fell into a infinite loop. So I intentionally crash the program execution with the Control+C. So can we make a modification to run it at our own will. So we have to count something that it should run 5 times, 10 times. So that is going to be something important. So let's define a counter. So I define a counter I count. So since I'm going to start it from I, the name I, so it will be by default identified as an integer, right? So I count equal to 0. So if it has executed this statement for once, so I can write here that, okay, this statement has been executed for once. So I can say now I count is equal to I count plus 1. This is known as the update procedure in computer programming. So the old value of I count in this line will take an increment of 1, and the value will be stored in the I count. So I count has been updated, right? And now we can write a condition on the value of I count. So I add this statement here. I say if I count is less than or equal to 5, go to 10, less or equal to, right? LE is for less than or equal to 5, right? So this is going to be executed. So when I count is equal to 5, it will again go for running, and then it will print the segment, something which is between the GOTO statement and the label 10. And to confirm it, let's write print asterisk I count equal to, and I say write I count, right? So the first part, this part is to print it as such, as a label, and this is going to print its value. So let's save it and run it. So let's test this program. Well, we have saved it. Yes, it's with blue flag. Now let's run it. CLS. If I have to recompile. So with the up arrow key, I repeat the compilation command. It will override the old executable file. No errors. The second program has been compiled much quickly than the first one, right? And everyone was surprised, and I was stunned while looking whether there is a problem in the program or not. But it worked. And now we are ready to see the success, or just the outcome, not the success, just the outcome of our experiment. Repeat. So it wrote hello world and then say, okay, 1. Hello world, I count 2, 3, 4, 5, 6 as it was expected, right? Now, these are the numbers. So with every number, you can add many functionalities to this one. You can compute the summation of these things. Here we have computed the sum of the I count value. So you can derive many summations. So you can compute the sum of arithmetic progression, geometric progression, and many things which requires the summation. So let's stop at this point.